Good evening to one and all. In this video, we are going to discuss about the RAM working memory. So we call it as random access memory or read-write memory. In the previous video, we discussed about the program memory and the different types of program memories. Okay. Now, RAM stands for random access memory, and it is the data memory or working memory of the controller or processor. So unlike ROM, RAM is volatile. So that means when the power is turned off, all the contents are destroyed. So that means the contents in the memory are lost when the power goes off, or when the power is turned off, or when the power is interrupted. So RAM is a direct access memory, meaning that we can access the desired memory location directly without the need for traversing through the entire memory locations to reach the desired memory position. Random access. So that means if you want to access a desired memory location, you directly go to that location. You directly go to that location to reach that location. So that's why it is called random access of the memory location. So these are the three different types of RAMs: SRAM, DRAM, and NVRAM. Static RAM cell, dynamic RAM cell, and NVRAM. Now, SRAM. So SRAM is nothing but static RAM, stores the data in the form of voltage. So SRAM should be made of flip-flops. Okay. So SRAM cells, each SRAM cell contains a flip-flop. Do you know the flip-flop? A flip-flop is a memory device which stores only one bit of information. So a flip-flop is edge triggered. So that means it can be either positive edge triggered or negative edge triggered. Okay. So in a typical implementation, an SRAM cell is realized by using 6 transistors. How many transistors are used to implement one SRAM cell? 6 transistors. And 4 of the transistors are used for building the flip-flop part of the memory cell, and 2 for controlling the access. Okay. Now see here in this diagram. So these 4 transistors are used for implementing the flip-flop, and these 2 transistors are useful for controlling the access. So whether you are going to read the data from the cell or write the data to the cell. Okay. So that will be decided by these 2 transistors. And the static RAM is the fastest form of RAM available, and the SRAM is fast in operation due to its resistive networking and switching capabilities. Okay, so this is the word line. So at the word line, you can give the information. It can be either 1 or 0. Okay, so this is the bit line B bar, and this is the bit line B, and this is the SRAM cell. Okay. So next one, DRAM. So DRAM is nothing but dynamic RAM. So the dynamic RAM stores the data in the form of charge. So the main difference between the static RAM and dynamic RAM is SRAM is made of flip-flops and DRAM is made of transistors. Okay. So this transistor is having the leakage property. So that means the data is stored in the form of charge. They are made up of MOS transistor gates. The advantage of DRAMs are its high density and low cost when compared to the SRAM. The disadvantage is since the information is stored as a charge, it gets leaked. There will be a leakage property. Okay, now so due to that leakage property, the charge will be lost. The charge will be lost. In order not to lose the charge, so the DRAM cells needs to be refreshed periodically. Okay, so that means we need special circuits called DRAM controllers. They are used for refreshing the operation. So the refreshing operation is done periodically in milliseconds interval. For every 2 milliseconds or for every 3 milliseconds or for every 4 milliseconds, you need to refresh the data. So this is the word line and this is the bit line and this is the capacitor which is used to store the charge. Next one. So this is the basic difference between SRAM cell and DRAM cell. SRAM cell is made up of 6 CMOS transistors and it is made up of MOSFET and a capacitor. And it doesn't require refreshing. It requires refreshing because the charge is lost. Low capacity, less dense, and high capacity, highly dense. And this is more expensive and this is less expensive. And SRAM cells are faster. Access time. Access time is the time required to access that particular cell is nothing but the access time. That is called 10 access time. For SRAM cell, it is in the range of 10 nanoseconds. And slow in operation due to its refresh requirements. So typically access time is 60 nanoseconds, and write operation is faster than read operation in the case of DRAM cell. And the last one is NVRAM, non-volatile memory, and this is random access memory with battery backup. Okay, and it contains static RAM based memory and a minute battery for providing the supply to the memory in the absence of external power. You know that the RAM is volatile. Okay, so that means the contents are lost when the power is interrupted. Okay, if you want to provide the battery backup to that random access memory, then it will become NVRAM, non-volatile RAM. Okay, so the memory and the battery are packed together in a single package, and the NVRAM is used for non-volatile storage of results of operations or for setting up of flags, etc. The lifespan of NVRAM is expected to be around 10 years. And the best example here is the DS1744 is an example for 32 kilobytes NVRAM. So this is about the random access memory or working memory or data memory and the different types of random access memory. Okay, so that's all today. Hope you understand this video. We will meet in the next video. Thank you, one and all.